Geomorphology is the science that studies the origin and development of landforms, such as slopes, valleys, beaches, dunes, caves, etc., over time, and seeks to investigate how these landforms combine to form landscapes. In this context, it can also be defined as the study of the morphological evolution of the landscape. Geomorphological studies include the quantitative analysis of landforms, the monitoring of surface and near-surface processes, and the characterization of changes in relief that occur in response to factors such as tectonic and volcanic activity, climate and sea level changes, and human activities. Investigations can be directed mainly towards the reconstruction of previous processes and changes in relief, in the sense of understanding current processes and forms of relief, or in the sense of predicting future processes and changes in relief. Currently, due to the direct relations with other areas of knowledge and with the use of new technologies, geomorphology experiences greater possibilities to understand the evolution of the landscape and the dynamics of geomorphological processes. The coast is a dynamic area. Wind, waves, rain, river discharge, volcanism, ice melting, and some other biotic and non-biotic elements constantly act to reshape this ocean edge. The removal, the transport, and the accumulation of sedimentary materials are the key mechanisms of this unstoppable reshape over the coast. The coast is also the place where people have some contact with the ocean. People walk, live, swim, play sports, and eat. The coast can be shaped and influenced by man's activities. The coast is the start and end point of several journeys. Whether on a sandy beach, in a mangrove, on a coral reef, or in another coastal environment, the ocean's edge is a diverse and fascinating ecosystem. It's the place where continental and oceanic processes meet. The coastal ecosystem reveals the interaction between the lithosphere, biosphere, atmosphere, and hydrosphere. Coastal ecosystem maintains habitats for a wide variety of organisms, but also offers resources and housing to sustain human life. The Earth's surface dynamics is studied by a large group of fields of the knowledge of science, like biogeochemistry, geochemistry, geology, hydrology, geomorphology, biology, engineering, human dynamics, and atmospherics. Coastal ecosystems are subject to physical forcing through a whole suite of environmental variables operating over multiple space and time scales. Let's see what is next. This is a very important graph. It shows the relationship between coastal sedimentary feature scale and their temporal variability, together with the four major time-space paradigms used to study the coast. Coasts are one of the most dynamic environments on Earth and one of the most responsive, much visible with the naked eye. As most coastal studies focus on a component of the system, example, a sandy beach or an estuary, usually over a limited time frame, they must adopt the appropriate length and time scales to both observe the process and the bad responses and observe the feedback between the two. In this graph, the y-axis on the right presents the scale of processes ranging from waves up to climate change. This axis includes from the bottom the tides, the wave trains, the tidal cycles and the storm events, the seasonal wave climate, the annual wave climate and the tide regime, the cycles of wave climate, the sediment supply, the sea level, and tectonics. Those processes are related to multiple time scales that can be seen in the left y-axis. The time scale in which the processes occur varies from a second time period to the millennial time scale. It also includes from the bottom the scale of hours, days, months, seasons, years, decades, centuries, and etc. At the x-axis, we can see the spatial scale, which includes the length of our interest features. They range from the left, considering the millimeter scale, up to the right, where is 1,000 kilometers scale. Inside the graph, there are four major time-space paradigms used to study the coasts. From the bottom, we consider the instantaneous scale, where ripples and ripples migration and modification rely on the time scale of seconds to days and are restricted to small spatial scales, reacting to waves and tidal processes. Then, the event time space scale is in this one, the investigations about seasonal beach cycles are taking monthly to annual timescales, considering some regional spatial scale and react to seasonal wave climate processes. The next one is the engineering large scale, where investigations range from years to decades and maybe centuries timescales regarding processes that include sediment supply and long-term wave climate cycles. Those investigations also deal with larger spatial scales. Finally, the geological time-space scale deals with processes that occur from centuries to millennial timescales and focuses on climate change, tectonics, and sea level oscillations processes at a spatial time scales of hundreds to thousands of kilometers. These are some factors controlling coastal development, modified from Davies, 1972. There are some factors from the land, and we can talk about geological structure like plate tectonics, mountain range, continental shelf width, and relief. We can talk about local geology, like local structure, rock types. We can talk about geomorphic process like river valleys, deltas, sediment supply, and isostatic sea level change, tectonic isostasy, glacial isostasy. And there are also facts of the ocean controlling coastal development. And these are eustatic sea level change, like glacial isostasy, geoidal changes, wave climate, water body size, orientation of the coast, wind and storm climatology. Can talk about tides, tidal range, tidal type, tidal currents. We can talk also about ice effects, shorefast ice, winter ice cover, also local erosion and deposition, coastal erosion, transport and deposition process, and biological effects like mangroves, the presence of mangroves, salt marshes, coral reefs, seagrass beds, coastal dune vegetation, etc. This graph is also extremely important. It presents the morphodynamic relationships between boundary conditions like topography, inputs from the atmosphere, from the ocean, terrestrials and autogenic sediments, and interactions like those in the central boxes, including coastal flows, boundary layers, sediment transport, sediment balance, erosion, and deposition. And the resulting surface morphology, again the topography and underlying stratigraphy in the coastal environment. This is the core of landform morphodynamics. We must be aware of both the interrelationship between the bed response morphology to processes, dynamics, and the ensuring positive and negative feedbacks between the two as they work towards an equilibrium relationship. That equilibrium is rarely achieved, hence driving changes. This map from Viles and Spencer, 1995, shows the global tectonic condition of the coasts. And we can see that some examples of South America, Africa, and continental China, the coasts are quite different from its global tectonic origins. In South America, we have the eastern part, where is Brazil. We have this mature passive margin coast with distal origin. In the west, we have convergent margin coasts. Africa presents mature passive margin coasts, and continental China presents marginal sea coasts. We are going to talk about this later. This map and these graphs are also very important. They show the global distribution of sandy coasts and was constructed by Lugendick and his collaborators in 2018. The colored dots along the world's shoreline represent the local percentages of sandy shorelines. Yellow is sand, dark brown is non-sand. The subplot to the right presents sandy shorelines, relative occurrence by degree of latitude, where the dashed line shows the latitudinal distribution of sandy shorelines reported by previous studies. The lower subplot represents the relative occurrence of sandy shorelines per degree of longitude. The curved dashed gray lines in the main plot represent the ice-free shorelines boundaries in their analysis. The underlined percentages indicate the percentages of sandy shorelines averaged per continent. Their analysis showed that 31% of the ice-free world shoreline is sandy. The continent with the highest presence of sandy beaches is Africa, 67%, while in Europe only 23% of the shoreline is sandy. Asia is sandy in 35% of its coasts and Oceania is 32%, North America 33% and South America 27%. The global latitudinal distribution of sandy shorelines shows a distinct relation with latitude and climate. No relation is found with longitude. The relative occurrence of sandy shorelines increases in the subtropics and lower mid-latitudes, 20 to 40 degrees, with maxima around the latitudes near 30 degrees south and 25 degrees north. In contrast, they are relatively less common in the humid tropics, where mud and mangroves are most abundant due to high temperatures and rainfall. The percentage of sandy shorelines decreases beyond the 50 parallel. This latitudinal distribution of sandy shorelines is in line with the latitudinal variation of the common sediments in the inner continental shelf, also reported by previous studies. This map, built by Gunn and William 2012, shows the global wave environment, and colors represent the annual mean power density of waves along the global ocean, and we can identify areas of major energy and minor energy along the global ocean. So, which areas of knowledge do we talk to directly? In oceanography, mostly about physical and geological oceanography topics. With geographers, we talk and urban planning, we talk about coastal management issues, coastal hazards and geomorphology, obviously. With the biologists, we talk about marine biology, coastal ecosystems, fisheries. To geologists, we talk about marine geology and geophysics, and with the engineers in engineering, we talk about coastal works, port and marine operations, oil industry, and so on. In the first exercise, you are supposed to do some research on the internet to find 5 scientific papers about 5 different topics presented today. PDF files must be sent to my email address. Enough for today. See you soon. Take care and be safe.